Good afternoon. My name is Konrad Patkowski. I'm a professor of chemistry at Auburn University in the United States. And our guest today is Humahuti Dihingia, who is a PhD student in the PHYMOL network and at the physics department at Nicolaus Copernicus University in Toru. Even though she's at the physics department, Humahuti is an expert on theoretical and computational chemistry and has a very exciting research project. Humahuti, could you tell us about your project a little bit?
Yes, thank you for the introduction, Konrad. I am a PhD student in this PHYMOL network, and currently I am working in the theoretical development for these intermolecular interactions. So we all know how intermolecular interaction can be important in our everyday life in general, starting from the very existence of the water as we have. So to understand the fundamentals of this interaction between the molecules, so we can do it using the laws of quantum mechanics or the quantum chemistry, you can say. So these intermolecular interactions are very weak, but these are very important. So here in these cases, the weak becomes kind of like heroes here. So to understand that, we can use the quantum mechanics, the laws of quantum mechanics, to find how these intermolecular interactions can be understood theoretically. So in my project, we are working on the theoretical development for different interactions involved, and to understand how the interaction can be understood in physical way. So in my project, we are working on developing a new approach which will help us to understand these intermolecular interactions in fundamental manner, for better understanding for these fundamental forces, which are very important.
I like how you brought up the understanding as a very important element that you're trying to achieve. So when a chemist or a material scientist uses your method to study an interaction, what kind of understanding can they get from this calculation?
Okay, for these intermolecular interactions, so we can understand, like we have like molecules. So inside the molecules there are so many quantum effects going on. So but to address it, we'll have to go beyond we'll have to look into the molecule to see what's there. So when we do that, we understand that those forces can have implications, like there will be electrostatic contributions, there will be like some effect due to the polarizations between the molecules, and also there can be other kind of interactions, such as the repulsion effect, which becomes very strong when you come closer, very close to each other. In terms of to answer your question, so we can understand how two molecules
influence each other.
Yes, how they influence each other. Yes, and how we can understand the existence, or what makes them stay in some equilibrium, and also what will happen when we go even closer. So yes.
So I think that's a crucial point, that we are not just understanding better how these molecules interact with each other, but maybe predicting if a new molecule will have the interaction another one.
Yeah, I think you are right. So we can with this thing we can without performing the experiments, we can theoretically we can predict what are the molecules they can exist. So that can be very important in terms of the in terms of modeling some of those molecular behavior, which is very important in terms of drug design. But that's like the very but we are working on the very fundamental, but eventually it can be used to model those interactions better, so that we can have better predictions in terms of those research. Yeah.
So, in your day-to-day studies, how do you investigate those molecules? So you have a new method. So what it means to work on a new method, what it means to get the new method to a stage that somebody can use it.
Yeah, that's like also I have been learning as a part of my project. So like I really appreciate the question, because this gives also like I'm getting a new insight how a new method can be introduced into the theory. So there we start with like, as always, like we have the maths, like which describes all the laws of nature, and it's very interesting to see that how those maths can those equations can like govern the laws of molecular interaction as well. And to have a theoretical predictions depending on the laws of quantum chemistry, I would say, and then to see those then to actually apply those. Yes, yeah, yes, exactly. Like, so to apply this, so we start with like with the foundations of we first start with the theoretical development, then we make some theoretical predictions, and we use those theoretical methods to calculate some of the properties. You can like properties in general, like for our case it can be different, but I'm saying about in general. So depending on our predictions, we try to validate, is this what we are getting or not. So we make the hypothesis, and then we validate it against those results. So in terms of my work, so we start with those we start with basic quantum chemistry methods. So in our case, it is like the wave function based method. So we start with that, and then we try to and it involves like programming. A lot of programming is a part of my project. So I need to implement those equations into those programmings. Then we can get a we can validate our results depending on that. Yeah.
And this is, I think, quite fascinating, because you clearly need to combine several very different skills. You derive equations on pen and paper, you program them, and then you actually use chemistry using the data that you get from these. So do you have a favorite part of this multi-step job?
Yeah, I think to answer your question, I quite enjoy like all of it, to be honest, but always to like combine the maths to the coding is always like interesting, because you can see how it actually works in terms of those equations, and that's like combining the maths and the coding part is really interesting, and to see it with your eyes, and it's really nice.
Yes, that's fascinating, and I think I share this really fascination. Let me shift gears a bit. So you're quite an unusual graduate student in a sense that you belong to the PHYMOL consortium, and in addition to doing your work in Torun, you also spend some time at another institution and also interact with a bunch of other researchers and students. Could you tell us, please, a bit how the participation in PHYMOL, how it changed your research? your outlook?
Like as a part of PHYMOL, of course, it's like has been a really like rewarding experience from the very beginning. It was as always, like science in most cases it's like mostly collaborative thing. So to be a part of this PHYMOL network, it gives us a exposure to the platform to collaborate with the experts in this field. So that is probably not possible in any other like doctoral project. So I'm really grateful for this opportunity. And also like as you have mentioned that I did have some research secondment with my co-supervisor in Queen Mary University of London, so with Professor Elston Mishkuta. So that was the time I got to really work with people from a different big like academic environment. So I was in Toronto, then I was there in London also, and it was really like a nice experience to just to experience it, and also to have those scientific discussions, which is like a next step for this was kind of like a next step for my PhD in terms of my PhD work. So I really appreciate and I really value this opportunity to be a part of this PHYMOL, and also to meet with other graduate students is also like a really good experience. So we can share the same like enthusiasm for science, so which can keep us going, and to have the supportive environment altogether in both in terms of science and also in terms of as to grow as a person. So I really appreciate that part of this project.
Yes, so science is so collaborative, and
Yes.
I think the PHYMOL network models that well.
Exactly. Yeah.
So imagine, I'm sure when you started in PHYMOL, you had some expectations, but you didn't really know what will happen. So is there something unexpected or particularly interesting or different that you experienced or learned that your old self wouldn't expect?
Okay, yeah, I think I must say that to be part of a broad scientific community, so I had to like and we were also like had those some of those like workshops regarding the science communication stuff, which I'm really passionate about, but I was not really like working on it. But PHYMOL gave me an opportunity to try those skills and work towards it. So I think like that was like I probably was not having on my mind, because I was expecting the scientific aspect will be great, of course.
But not.
Yeah,
other
but
part.
to have this like scientific like communications and to develop those skills altogether, I think that's definitely a bonus I didn't expect.
Oh,
Yeah.
absolutely.
Yeah.
So when you graduate with a PhD, with all of these experiences, where do you see yourself in the future? What is the next step for you, Humahuti?
Definitely, like I'll be I want to stay close to the research, but with my experience and opportunities available, I'd like to try like something maybe close to academia, or maybe something to industry also, but I definitely want to stay close to the research aspect.
Thank you, Humahuti. That was fascinating. So we just learned how Humahuti Dihingia, a student at the PHYMOL consortium, advances her research and at the same time benefits from collaboration and interaction opportunities with other researchers and students in PHYMOL. And we will hear from another PHYMOL student soon. Thank you.